test the claim that for the adult population of one town, the mean annual salary is given by mu equals to 30,000. So in other words, the claim is that the average salary of one town is $30,000 per year. But you have the sample, and for a sample of 17 people, you got the mean value as 22,298. This is probably the mean value, x bar. And the sample standard deviation is 14,200. And you use a significance level of alpha equals to 0.05. Okay, so for this one, you have to notice that the sample size is only 17. So that's less than 17. Less than 30, so n is less than 30. And you're not given the population standard deviation, but the sample standard deviation, 14,200. So that means that we are forced to use the t distribution as opposed to the normal distribution. Okay. So keep that in mind. This would require a t distribution. And we want to use the formula, well, we first have to figure out the null hypothesis and the alternative hypothesis, because this is testing the claim, right? So testing claim means you have a hypothesis testing, so you have to figure out what the null is, what the alternative is. Because you have mu equals to 30,000, that becomes the null hypothesis, because every time you have an equal sign, that's the null. And and what you want to prove is that you want to prove that this is not right. Okay, so to test whether this is right or wrong, you have to show that this is not true. Now, you should read this question carefully and recognize that we're not trying to prove that the income is less than 30,000 or bigger than 30,000. Had the question be phrased as like, test the claim that the average income is less than 30,000, then that would just be mu less than 30,000, and that would give you a one-tail test. But here it's simply trying to see if this claim is true or not. So that's put as the null hypothesis, and the alternative hypothesis would simply be the opposite of this, which is mu not equals to 30,000. Alright, so once you have established this, now we should do the t-score. The test statistics will be written as t, and it's still the same formula as x bar minus mu divided by sigma over n, square root of n. But because we don't have the population standard deviation, we should scratch this out and put s instead of it, because that's the best you can do, right? The sample standard deviation. And although they don't say it, but sample standard deviation is already Bessel corrected, so you don't have to worry about whether this was obtained by dividing by n-1 rather than n or not. Okay, so that's the formula, and let's find the test statistic. This would be 22298 minus the 30,000 divided by 14,200 over square root of 17. And when you put this into your calculator, make sure that you have these parentheses, because without it, the order of operations can give you a totally wrong answer. And let's use a calculator to do this calculation. So you have turn it on, and then we have parenthesis 22298 minus 30,000, close the parenthesis, and then divide, open the parenthesis, 14200 divided by square root of 17, and parenthesis, enter, and you get negative 2.23. So the value, or negative 2.24. Okay. So what do we do with this? Well, we have to calculate the p-value to see if it's less than the significance level or not. If it's less than the significance level, then you can reject the null hypothesis. If not, you cannot reject it. So okay. So because this is a two-tailed test, the rejection region will be this shape. You have shading in both directions. But if we're to use the p-values, this is what's going to happen. Here's negative 2.24, right? And the p-value would be the area of the shaded region given by this boundary, negative 2.24, and also positive 2.24. So whenever you get a value, you have to put both the plus and the minus of that value if you're using the two-tailed test. So we have these two, and now we can calculate this p by doing the Normalcdf function. So let's try the Normalcdf. Second vars, Normalcdf. Let's clear this. Put negative 2.24, and that gives you negative 0.0125, right? So you get negative 0.0125. Oh, but the problem is you also have this as well as the left side. Okay, there's no minus, sorry. Positive 0.0125. Right. Okay. But because this is just one side of the shaded area, you have to double this. So one thing that's important is that for two-tailed, you have to do 2 times the area that you get, okay? So we have to take the twice of this one, which would be 0.025. So that's our p-value. P-value would be 0.025, and because this is less than the significance level, 0.05, we can reject the null hypothesis and adopt H1, okay? So when you write the conclusion, you should, I think, sufficient evidence or insufficient evidence, that's like the good word to use. So in here, we have sufficient evidence to show that, or there is sufficient evidence to show that the average annual salary is not 30,000. Okay, so that's what we have. Yeah. So because you wanted to test the claim that the average is 30,000, it's good to write the conclusion as that this is not true. Okay, so you could also say that we are 95% confident that average mean annual salary is not $30,000. So that would be another way to say it.